My name is Ridhdhi and I am a master's student in the Department of Chemical Engineering in Dr. Heather Sheardown's lab. So today the activity that I will be doing with everyone is called Fun with Bernoulli. What this is basically focused on is, even though we know that air exists all around us, we usually don't notice air pressure. During this activity, students will be learning about Bernoulli's principle on how to manipulate air pressure, and how it influences all the objects around us. And the way that this has an engineering connection is because engineers understand Bernoulli's principles, engineers can manipulate the air pressure around them in their design controls to stabilize everything from rockets to helicopters to blimps. While designing airplane wings, engineers apply Bernoulli's principles to create that lift. And even in cars and trains, they take advantage of Bernoulli's principles in order to help move the vehicles at high speeds. So the learning objectives of this activity is that at the end of it, students will be able to explain that air pressure decreases as the speed of air increases. They'll be able to explain that air pressure acts in all directions, not just up or down. And they will be able to explain that engineers use the understandings of air pressures to make airplanes fly. So before I get started, if you guys have any questions, you can post them in the comments and I will try to answer them the best as I can. So the materials list, before I begin the activities, I'll just read them out again. So you'll need one piece of paper, it could be new or recycled, 2 round balloons, so I have these pink ones here, 2 pieces of string, so you can actually take the string and tie them to the balloons if you'd like, because that's what we'll be doing with them. You'll need you'll need 1 plastic cup, and you want to fill it with a bit of water, and you'll need 1 ping pong ball and 2 straws. So 1 straw can be left as is. It's a little bit easier if you have one of these bendy straws. And then the second straw can be cut in half. So I'll give about a minute for everyone to settle all of their equipment, just to make sure you have everything. So I'll repeat that. The 1 cup of water, just fill it with the 1 cup, fill it with half a cup of water. The 2 balloons, just tie the string to them, and then the 1 piece of paper that you have, you're going to want to fold it in half. So the first activity, so I'll just give about a minute again. The first activity that we'll be doing is called the paper tent, and so when we begin, we're going to have the students fold the paper in half lengthwise to make a paper tent. And then we're going to kind of set it on the table like this. I'm going to ask the students to predict what they think might happen when you blow right through the middle of the tent. So that basically means, like, do they think it's going to go down? Do they think it's going to kind of go upwards? Do they think it's going to flatten down? Do they think it's going to blow to the side or any of the sides? What do they think is going to happen? I'll just give everyone 30 seconds. All right, so I'm going to actually do it and we're going to see what happens. So you're going to want to blow air through the middle of the tent and we're going to see what happens. Did you guys see that? I'll do it again. So blowing air right through the middle. So what you're seeing is that when you do that, the tent actually flattens out. So I'm going to try that once again. Sorry, you're going to want it to be a little bit wider apart. So you're blowing air right through the middle again. So what actually happens is the tent flattens, and this is because there's air moving through the inverted V. When you're blowing air through it, through the inverted V shape of the tent, the air that's flowing through it has less pressure than the air that's surrounding it. So when that happens, because the pressure is higher on the outside, the tent tends to flatten around the paper and pushes it downwards. So that's sort of one of the neat things that engineers use when they're designing planes and stuff. The next activity that we're going to do is with the balloons. So as I mentioned previously, you're going to want to blow them up a little bit and then tie the strings around them. So kind of like what I have here. You don't need to blow them too big. This is generally good. My balloons are a little staticky right now, so hopefully that should be okay. So I'll give everyone about 30 seconds. And yeah, if you have any questions, please put them in the comments, and we can also answer them later on as well if you leave them in the comments. So with this activity, what we're gonna do is we're gonna wow, these balloons are super staticky. I think I'm making them more staticky, but that's okay. So what we're gonna do is we're gonna hold the balloons together and we're gonna see what happens when you blow air through the middle. So do you think they're gonna go further apart, or do you think they're gonna go sideways, or do you think they're gonna move closer together? You guys can record your hypotheses, which is basically what you predict might happen when you blow the air through them. So you wanna hold them about 4 to 6 inches apart and just blow air right through the middle. So I'm going to show it and do it right now. Okay, my balloons are a little staticky. Okay, so did you guys kind of see what happened there? So when you blow air through the middle of the balloons, they should move closer together. What this is happening, the reason why this happens is the same principle as what you saw with the paper tent. So when you're blowing air right through the middle, the air pressure that's in between the balloons is lower than the air pressure that's surrounding the balloons. And so what that causes is a pushing effect, which pushes the balloons closer together. So that was the second activity. The third one we're going to do is called Bernoulli's water gun. So that will be with your cup filled with water. And then what we want to do is we want to take our one straw and cut it in half. So I'll give everyone about 5 seconds to do that. And while we're doing that, what we're going to want to ask, what I'm going to ask everyone is to see what do you think will happen when you blow across the top of one straw while the other one is in the water. So what I'm basically doing is I'm putting the one piece of the straw into the water and I'm holding it down, and I'm going to put the second one at a 90-degree angle, sort of like this. And when I blow across the top of one straw, what do you think will happen? And once you predict that, you can note down your hypotheses and see what you think might happen, whether you'll get like a bubbling effect inside of the cup, whether you think the water is going to spray out across the top, or what you would think might happen. So we're going to call this the blower straw, and this is the one that's going to be in the water. So we're going to do what I said. We're going to blow like really hard across into the straw that's at a 90-degree angle, and we're going to see what happens. So it might be a little bit hard to see, but on the camera at least, but basically what happened was that when I'm blowing across the top of one straw, the water actually sprayed out. So I can see a little bit of the water on my computer, but that might have been hard to see on the video. So basically the water rises up in the first straw when you blow across the top of the second one. This happens because the air that is blowing across the straw in the cup reduces the air pressure at that point, and the normal air pressure beneath pulls the water upwards into the straw, and the moving air blows the water out and across the room. So this is why you get that spraying effect. The last activity that we're going to do is we're going to take the ping pong ball and we're going to take the straw. What we're going to see, what we're going to try to do is we're going to try to predict how we would get the ping pong ball to float with just using the straw, kind of float in the air. So we're going to use all of our Bernoulli's principles that we just learned about and see how we can do that. We can make it float. So what I want everyone to do, I'm going to actually show you guys how to do it. What I want you guys to do is I want you guys, if you have the bendy straw, so when it's straight, just bend it to a 90-degree angle. You unfortunately will not be able to do this if you have a straight straw, unless you're lying flat on the ground and you have a straw just like in your mouth, like 90 degrees. That's a little bit tricky. And then you're going to want to place the ping pong ball right on top a little bit, and then you're going to blow really hard through the straw, and you'll be able to get it to float in the air. And that you can do that for about 30 seconds. So I don't know. So normally when you're not doing that, what you see is that the ball falls when there's nothing kind of helping it stay upright. And it falls due to gravity. But when you're blowing air from the straw, you're creating an equal balance between the force that's coming from the air pressure that you're generating and the force of gravity, which helps the ball sort of levitate in the air. So those are sort of like the principles that they use in order to, help your airplanes fly or even launch your spaceships. Those are all of the activities that I have today. And I hope that what we learned today kind of gave the students an understanding of how air pressure decreases as the speed of air increases, how we got to explain that air pressure acts in all directions and not just up or down, and also explain how engineers use different principles of air pressure in order to make airplanes fly. If you guys have any questions regarding sort of the activities that we did today or the principles that we discussed, please leave comments in the video. This video will be posted on our channel, and you guys can kind of ask any questions when you're watching it later on or as they come up. And if you have any questions about the kind of work that we do in our lab and as part of the C2020 network, please feel free to post them as well, and we'd be happy to answer them. Thank you so much for watching today, and I hope you guys had fun with Bernoulli.